Hello student, this is Ravi sir from Devashay International Public School. Last time we had completed 14.1 exercise from the chapter Factorization, and today we are going to start with the exercise 14.2. Now before we start the exercise 14.2, we need to memorize some of the identities, we need to look into some of the identities through which we can factorize the expressions, right? So these are the four identities which we need to keep in our mind. Right, the first one is whenever there is such an expression a plus b whole square, we can write it as a square plus 2ab plus b square. When we have the expression a minus b whole square, we can write it as a square minus 2ab plus b square. When we have the expression a square minus b square, then we can write it as a plus b into a minus b. And lastly, when there is an expression x plus a into x plus b, we can write as x square plus a plus b into x plus ab. So we will start with the factorization exercise 14.2, question number 1, Roman number 1. Now see, whenever we need to factorize any expressions, first we need to observe that expression, right? Now we need to observe this expression. This is a square plus 8a plus 16. Clearly we can see that the first term and the last term, that is the third term, both are a perfect square, and the middle term, it has a sign plus, right? So looking into these identities, we can use the first identity, that is a plus b whole square is equal to a square plus 2ab plus b square, right? So first of all we can write the identity a plus b whole square is equal to a square plus 2ab plus b square, right? So this is the identity we need to use. Okay, now before factorization, student, this is the expression. We need to modify this expression in such a form so that the modified form fits into the right hand side of the identity. Okay, this is the right hand side of the identity. Let me again write this expression once again. A square plus 8a plus 16 can be modified like this: a whole square, then we can write the last term, which is actually easier to write, so we leave the space for the second term and we'll write the last term, that is the third term. This is 16. We can write 16 as 4 square, and the middle term we can write it as 2ab in this format. So 2 into a is ra and b is 4. When you multiply 2 into a into 4, you already get 8a. Okay, so we have actually modified our main expression into such a form so that it fits into the right hand side of our identity. You can actually compare these. We have modified it. Now, if the expression corresponds to the left hand side of the identity, then that is the desired factorization. Okay, so here we can clearly see this is a, the quantity which is in the first bracket, and the quantity which is in the last bracket is actually b. So this is your a and this is your b. Now we can factorize this by corresponding this left hand side of the identity, that is a plus b whole square. So we can write a plus b. What is b here? The quantity in the last bracket, that is 4. A plus 4 whole square. So this is your factorization. In the same way we can do the one more expression. Clearly after observing the expressions, p square minus 10p plus 25. Here the first term and the last term are clearly the square, perfect square, and the middle term has the sign minus, negative sign. So we need to use the formula for the identity a minus b whole square, which is a square minus 2ab plus b square. So first of all, let's write the identity a minus b whole square is equal to a square minus 2ab plus b square. So we have written the formula. We already identified which formula we need to use, and now we need to convert this expression in such a form so that it fits into the right hand side of our identity. This is the right hand side of the identity. So let's once again write this expression. This is p square minus 10p plus 25. This can be written as p square can be written as p whole square. As I told you, the middle term is going to be the negative term. Now we are not writing the middle term. First we will write the last term because it will be easier for you to write. The last term is 25, which can be written as 5 square. So this is your A, this is your B, the quantity in the last term, and we can modify the middle term. Middle term says 2 into A into B. So 2 into A is our P, into B. What is P? P is the quantity which is in the last bracket. So this is 5. Clearly, when we multiply 2 into 5 into P, we get 10P. Okay? So we have modified our expression in such a form so that that form actually fits into the right hand side of our identity. Now, we need to bring such an expression which corresponds to the left hand side of the identity. Then that expression is actually the desired factorization. So we can write it as, clearly this is A and this is your B. So we need to bring it to this form, A minus B whole square. So A is our P minus, this is your A and this is your B in the last bracket. Okay, so A minus B whole square. So P minus 5 whole square. So this is your desired factorization. Now student, question number 1, Roman number 3rd. Now we need to factorize this expression. This expression is 25m square plus 30m plus 9. So clearly, as we can see, the first term and the last term are perfect square and the middle term has a plus sign in it. So which formula we are going to use? The identity we will be using is A plus B whole square is equal to A square plus 2AB plus B square. Okay, and we need to convert this expression in such a form so that it fits into the right hand side of our identity. So let's once again write this expression as 25m square plus 30m plus 9 can be written as 25m square can be written as 5m whole square plus the middle term we will write later on because it will be easier to write, and the last term is 9, which can be written as plus 3 whole square, and the middle term is in this format, that is 2 into A into B. So the quantity which is in the first bracket is your A and the quantity which is in your last bracket is your B, and you can write the middle term as 2 into A, that is 5m, into B, that is your 3. Clearly when you multiply 2 into 5 into 3, you get how much? 30m. Okay, now the expression which corresponds to the left hand side of the identity is the desired factorization. So let us convert it into this form. So this is A plus B whole square. We have the quantity in the first term as A and the quantity in the last bracket is as B. So we can convert it as A minus B whole square. This is your A, 5m plus, this is your B, 3 whole square. So 5m plus 3 whole square is the desired factorization. In the same way, here again the first and the last term are the perfect square and the middle term is a positive sign. So again the same identity will be used, that is A plus B whole square is equal to A square plus 2AB into B square. So we can modify this term as 7y square, 49y square can be written as 7y whole square. We'll write the middle term later on. Last term is your 36z square, which can be written as 6z whole square. Now the quantity in the first bracket is your A and the quantity in the last bracket is your B. Fine, and the middle term should be in the format 2 into A into B. So let's write 2 into what is A, that is 7y What is B? B is your 6Z. Clearly, when you multiply 2 into 7 into 6, you get 84YZ. Okay? And the expression which corresponds to the left hand side of the identity is the factorized form. So, that is A plus B whole square. So, we need to write as A plus B whole square. What is A? 7Y. What is B? 6Z. So, 7Y plus 6Z whole square. This is your factorization. Last term, here, as you can see in this expression, you can take 4 as common. Okay, so I am taking 4 as common. The rest of the expression is x square minus 2x plus 2. Sorry, plus 1. So we need to factorize this. 4 is common. Again, as you can see, the middle term here in this expression is negative. So the identity will be a minus b whole square. Let's first write the identity. A minus b whole square gives you a square minus 2ab plus b square. As you can see, the middle term is negative. So we have the identity, this one. Now we need to convert this into such a form. Okay, so I am writing this expression once again. 4 is common. Again, a square bracket. X square can be written as x whole square. Middle term we will write later on. And the last term, 1 can be written as 1 square. And the middle term should be in the format 2 into a into b. So the quantity in the first bracket is your a, and the quantity in the last bracket is your b. So 2 into x into b. Okay, and now we can factorize as 4 into x minus 1 whole square. So this is your factorization. Question number 6. Expression is 121b square minus 88bc plus 16c square. The first and the last term are the perfect square. Middle term is a negative term. So the identity we are using is a minus b whole square, which is a square minus 2ab plus b square. Okay. So we need to actually modify this whole expression like this. Okay. So 121b square, which is a perfect square, can be written as 11b whole square. Right? Middle term is a negative term. We will not write the middle term right now. We will write the last term, which is the third term. That is 16c square can be written as 4c whole square. Now, this is your a and this is your b. And the middle term should be like in this format, 2 into a into b. So 2 into a. What is the a? 11b. What is your b? This is 4c. When you multiply 2 into 11b into 4c, you get 88bc. Okay. Now, how you are going to factorize? You need to bring such an expression which corresponds to the left hand side of the identity. That is a minus b whole square. We know this is a and we know this is b. So we can write a minus b whole square. So what is a? 11b. Negative sign. What is b? 4c. So 11b minus 4c whole square. This is your factorization. Again, in this expression, first of all, we need to expand this format. L plus m whole square. We need to expand this. Then later on, we need to factorize. So let's expand this. This is like a plus b whole square. We have written the formula a plus b whole square, that is a square plus 2ab plus b square. So let's expand this. L square plus 2 into L m plus m square. So we have expanded this, and the last term we need to write, that is minus 4 L m. Now these two are the like terms. We can operate the like terms. This is plus sign, this is negative sign. So we need to do the subtraction. So L square plus 2lm, this is minus 4lm, which gives you minus 2lm. And the last term is m square. Okay, so we have modified this in this format. Okay, but the thing is the middle term is negative, so we need to bring this in the form a minus b whole square. So this is your a. We can convert this l whole square minus 2 into l into m plus m whole square. So this is your a, this is your b, and we need to write a minus b whole square. So l minus b is your m whole square. So this is your factorization. Okay. Now here, as you can see, this is a raised to 4 plus 2a square b square plus b raised to 4. So we need to use this formula a plus b whole square, because everywhere there is plus. So a square plus 2ab plus b square. We need to modify this one. Let's write this expression once again. A raised to 4 can be written as a square whole square plus 2 into a square b square. And the last term, that is b raised to 4, can be written as b square whole square. Okay, so this is like a, which is in the first bracket, and this last bracket is your actually b, and we need to write in this format, that is a plus b whole square. So what is a? A square plus what is b? That is your b square and whole square. So we have factorized it. Okay student, now we will be solving question number 2 in exercise 14.2, in which from Roman number 1. Now here, as you can see, the expression is 4b square minus 9q square. So as you can already see that we can actually compare it with this identity. The identity a square minus b square is equal to a minus b into a plus b. Okay, so we just need to modify this expression. So let's just try. 4b square can be written as 2p whole square minus 9q square can be written as 3q whole square. Okay, so this is already in this format, a square minus b square. So we need to bring it to this format, a minus b into a plus b. Okay, so 2p minus 3q and one time plus, that is 2p plus 3q. So this is your factorization. Now look at this. There is 16x raised to 5 minus 144 x raised x cube. So we need to take x cube as common. Okay, so I am taking here x cube as common. The rest of the thing I am writing it inside. 16 x cube has been taken common, so we have x square here minus 144, and x cube has been taken common here, so nothing remains here. We can write this as like this: x cube square bracket 16x square can be written as 4x whole square minus 144 can be written as 12 whole square. So again, using the same formula, a square minus b square is equal to a minus b into a plus b. So we can write it as x cube 4x minus 12 into 4x plus 12. So this is your factorization. Okay. Now we have one more expression, Roman number 5th, L plus m whole square minus L minus m whole square. So again, this is again in this format. So we can use the same identity, a square minus b square is equal to a minus b into a plus b. Okay, so let's just try. L plus m, this is whole thing your a, minus L minus m. So one time we have done minus, second time we have to do plus. L plus m plus L minus m. We need to open the bracket. L plus m, this minus gets multiplied inside, So minus L plus M, L plus M plus L minus M. You see, minus L plus L gets cancelled, minus M plus M gets cancelled. So we have 2M, M plus M is 2M, into we have L plus L, that is 2L. So the final answer is 2 into 2, 4, M, L. This is your answer. Again, now we have one more expression here. You see the bracket part, x square minus 2xy plus y square. So this actually resembles with this identity, actually the right hand side of the identity, a square minus 2ab plus b square. We need to bring this expression into this format. So we can directly do it. This is x square minus 2xy plus y square can be written as x minus y whole square. And the rest of the part minus z whole square. So again we have the same formula, a square minus b square is equal to a minus b into a plus b. So we can write it like this, x minus y, this is your a, minus z, again x minus y plus z. This is your factorization. We have one more expression here. This is quite large expression. We have total 4 terms here. Okay. So how we are going to try this? We need to keep this term as separate and we need to keep this whole thing separate, and we can do it very easily. 25a square can be written as 5a whole square. And from the rest of the expression we can take minus as common, and the rest of the thing we can put it into bracket. So let's write it. So minus we have taken common, so we have 4b square. This is plus, because we have taken minus common outside, so this plus becomes minus 28bc, minus again we have taken common, so here we get plus 49c square. We can modify this expression by writing like this, 5a whole square remains as it is, minus we put a square bracket, 4b square can be written as 2b whole square, minus the middle term we will write later on. The last term is 49c square, which can be written as 7c whole square, bracket close. Now this first term in the bracket we have a, and this last quantity which is in the last bracket is your b. Okay, and we need to put the middle term like this, 2 into a into b. Okay, so 2 into a is your 2b, and what is b? B is your 7c. When you multiply 2 into 2b into 7c, you get back to back 28bc. So we have modified this expression according to the identity. Now we can 5a whole square minus, this is your a, this is your b, and the middle term has a negative sign, so we can write it as 2b minus 7c whole square. Again we can put a same formula which we saw last time, a square minus b square is equal to a into b, a minus b into a plus b. So 5a minus 2b minus 7c, and again one time we are putting minus and second time plus. So 5a plus 2b minus 7c. Opening the bracket, 5a minus 2b, this minus gets multiplied inside, so we have plus 7c, and 5a plus 2b minus 7c. So this is your factorization. Okay students?
Okay student, this is all about this exercise. We will continue with the rest of the sums from the same exercise in our next video. Thank you.